Okay, so picking where we left off, talking about building from scratch on page 27. So you have to ask questions. You have to say, hey, is this the way this thing works? And then you turn this thing into a data model. And the purpose of the model is to be able to show it off and say, is this what you told me? And then you do some transformation magic, and presto changeo, it turns into a database. So we'll be doing an awful lot of that coming up soon. The next topic is about redesign. I've got something from some other company. I've got a database from another company, and I'm migrating or combining things together. In corporate takeover world, this is a common thing, where you buy out another company and they go, well, we use Oracle. And you go, well, okay, I guess we're using Oracle too. And so, you do a giant project that moves everything in. And maybe they use, stock numbers that are different than your stock numbers. So, you're going to have to be doing an awful lot of work to make that happen. So on page 28, they talk about, why do I need to learn all this stuff? Well, to tell you the truth, database is a really good discriminator on a resume. Back when we were doing interviews for office workers, it would be like a team of people doing interviews. And somebody would ask, how are you in Microsoft Access and Excel and PowerPoint? And I would ask, how are you in databases? I didn't particularly say what kind of database. And practically everyone who showed up for the job knew how to do, Word and PowerPoint. But when it came to databases, it'd be like, So I use that as kind of a discriminator. Those people who actually know databases, to me, are more valuable and more important. Okay? So they have this thing called a knowledge worker. And a knowledge worker is the person you go to get stuff done. And this could be one of those things where you bypass the entire chain of command. The very top CEO of the company might walk down the hall and go sit down at the desk of the knowledge worker and say, I'm getting ready to put this thing for a shareholders meeting. Could you help me with this graphic to show this, 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 this? And the worker goes, yeah, I can write you a query on the database that produces that report. So you really want to be that person because you're a valuable person, right? Okay, if the top dog bypasses 3 or 4 levels of supervision to come sit at your desk to get you to do, design a report, yeah, oh boy, you want to be that person. And then programmer, the database administrator, those are high-paid folks. And so, you're an application developer, maybe you're on a web server or a client application or some sort of report. These are knowledge workers and programmers. Yes, they all go through SQL and they all use the database. And the database administrator is the one who actually does this part, and that's another highly paid position. The other ones who, add something to the table or change permissions or add users. So knowledge workers and programmers and database administrators, ooh, sweet thing to put on your resume, big time. Okay, so next we're going to talk about a brief history of how we got to where we are in the database world. So page 29, it used to be file-based. I had an application that had employee data in it. And so it was just a file. No file extension or anything. I mean, just a file out there that you wrote. And so it worked pretty good. It did everything I wanted to do. But whenever I wanted to add a new field, like for example, when we changed from zip codes being 5 characters to zip codes being 9 characters, I had to go back to the original programmer and go, hey, we need to make a change to this database, and they would have to go in and make some changes and make sure everything worked. So it's kind of clumsy. Plus, if somebody else in the organization wanted to be able to get to that data, well, tough, because it was only written for that one application. One application, one table. That's it. So it kind of sort of sucked. Anyway, very specifically tied to the application, and to make any tweak, I had to go back to the original guy. So I really kind of needed a database system, an honest-to-God relational database to take this over. Because I had a need for integrating multiple files. I mean, the HR department needs the same data from the employee table, so instead of having to create their own, I just want to be able to use theirs, right? And then, whenever you have tables that want to talk to each other, I really kind of need this integrated relational approach because that's how it works. So what if I ask you on a test question something about what's the difference between a file-based system and an honest-to-God relational database system, modern system? You'd be able to tell me, right? Okay, good. On page 31, they talk about the relational model. Again, this is that whole concept of, do I put it in one giant table or do it in 2 smaller tables? Well, there's a guy named E.F. Codd, worked for IBM at the time in the late 60s, early 70s, and he basically said, we need to come up with these small tables, and here's the reason why. It's a very important topic, not in this chapter, but coming up soon in Chapter 3, this is going to be something that's going to haunt your dreams for quite some time. So, a relational model. And then there's a section in the history talking about the post-relational model. And the idea is after this only stored text and numbers. But now databases can store, music files and video files and pictures, right? It doesn't have to be text. So object-oriented database. The web. The web put a lot of strain on databases. So when the web went crazy, you basically had some choices on where to put the stuff. Do I make the web server stronger, or do I make the database server stronger? Remember the way back here at the very beginning, we talked about some sort of a web server and the database. Do I make this guy bigger, or do I make that guy bigger? And so you have some choices. If I put it in the web, I beef up the web. If I put it in the database, I have to beef up the database server. Typically not in the same machine. So it's all about, where do I do the processing? Where do I store it? Whose CPU and memory do I use? There's some choices. XML, extensible markup language. This is the universal translator. If I can get it to XML, I can get it out of XML. It is text-based, so information that's this big in the database turns out to be monstrously huge in text, because it just explodes in size, sometimes by a factor of 3 or 4. Hey, but just because it don't mean it's bad. The no SQL movement. Now, a lot of people looked at that and said, no, oh great, I don't have to learn the structured query language. That is not what the NO stands for. NO stands for not only. So if you read it correctly, it's not only SQL. So the no SQL movement is not a movement to make SQL go away. Okay, just saying. And anyway, big data is the people who use this kind of stuff. Big data is a cool term. It basically means, I'm doing data mining and that kind of stuff, and my data is probably flattened because I've extracted some data out and I don't have all the details. I just have like a summary. So yeah, I can do other types of things. Cloud computing is a topic that comes up. Microsoft has one called Azure. Amazon has one. Google has one. There's lots of private cloud-based computing things, and they all have databases in the sky. So I could connect to my database, my Microsoft Access database, SQL database, in a cloud environment. It works just exactly the same. And then virtualization. That basically means virtualization and cloud computing kind of goes together. Virtualization means I actually have an entire PC somewhere that's fake, a fake PC. So inside my real PC, I have a fake PC. So inside my Windows 10 machine at home, I have a Windows 10 virtual machine. Yes, 2 different machines. Now, the hardware is all fake, but virtualization in the big world, virtualization allows me to ramp up the resources. Like if you're a tax prep company and you need lots of CPU and memory and storage during tax season, but after tax season is over, I can kind of crank it down. Well, that's perfect for cloud computing and virtualization, because I can crank up the knob, so to speak, for the month of April. Now, I'm going to pay through the nose for the month of April from my cloud provider. But after April's gone, I can dial it back down. Well, I don't need 18 CPUs. I'll go back down to 4. And so, being able to move, it's called elastic scalability. How's that for a cool term? Elastic scalability. Okay, we reached the end of this chapter, and please stay tuned for the next chapter.